With regard to this candle, it's very difficult to say how long it's been burning. One doesn't know when it was lit, one doesn't know how long the candle was at the start, and one doesn't know whether the rate of burning has remained constant, whether it was stopped during burning and then started again. And for that reason, one can't say by looking at it now as it is how long it's been burning. Now, the Earth and the solar system are to be compared to our candle. We don't know when the Earth was wound up and started to burn. We don't know whether the rate of burning running down, that is the rate of aging, has remained constant. And because we don't know these things, nobody was there at the start to tell us, it's very difficult to work out a method which will really date the age of the Earth properly. For this reason, we want to look into some of the methods which have been developed for dating the Earth and the solar system, and some of the objections which can be raised against them. We want to see whether these objections can be overcome.
A typical Dutch landscape, a picturesque small town near the Rhine River. And as everywhere in the world, but especially in very densely populated Holland, new houses must be built for more people. But then a discovery is made. While preparing the ground for building houses, some old remains of long-forgotten history are uncovered. Carefully, the remnants are collected for further investigation. And the first question is, how old are these things? Did we find an old Roman settlement, or perhaps a medieval village? How old are these wooden fragments, for instance? The dating laboratory at the University of Groningen will try to find out. And they will use for that purpose the carbon-14 or radiocarbon dating method. Nobel Prize winner and the inventor of this process, Professor Willard Libby, an evolutionist, explains the method.
The way it happens is that the cosmic rays put radiocarbon into the food we eat, and therefore we become radioactive with radiocarbon. And as long as we live, we keep eating, and the concentration is maintained constant. But once we die, we don't eat, and our body proceeds to lose the radiocarbon at the rate of 1/2 every 5,730 years. So by measuring the amount of radiocarbon in your carcass, I can tell how long you've been dead, and that's radiocarbon dating.
This is true not only for human beings, but for everything that is alive. Take, for instance, these beautiful gazelles. As long as they live and eat, both carbon-14 and carbon-12 enter and leave the body. The ratio of C14 and C12 inside and outside the body is the same. But when the animal dies, it stops eating, and then something happens. During a long period of time, gradually, C14 decomposes into nitrogen and leaves the body. After 5,730 years, only half the original amount of C14 is left. That's why we say the half-life of C14 is 5,730 years. Technically, it goes like this. After cleaning the sample very thoroughly, it is put into a high-intensity quartz oven, which can reach very high temperatures. There, the wood is completely burned in order to isolate the gases. Among these is, of course, the radioactive gas C14. After the burning, The gases are filtered by a complicated system of tubes and liquids in order to separate the carbon dioxide from the other gases. This purified gas is then collected and examined by a Geiger counter. There, the radioactive C14 particles are counted. A computer then calculates the age of the sample. By the way, our sample appeared to be from an old Roman settlement of 200 AD. Archaeologists all around the world have used carbon-14 in an attempt to determine the approximate age of their discoveries. The results have been useful in many instances, especially when involving remains that are not extremely ancient. Experience has shown, however, that C14 dating is far from foolproof. There are many important variables, some of which are still not fully understood. Unfortunately, C14 sometimes yields quite inaccurate results. Researchers used the system on a shell from a live clam. The test's results indicated that the clam had been dead for as much as 3,000 years. Dried up seal carcasses, less than 30 years old, have dated as old as 4,600 years. Even fresh carcasses have falsely dated at 1,300 years old. Contrary to a very important assumption on which carbon-14 dating is based, not all plants absorb radioactive carbon equally. Recent research has shown that some plants have a previously unknown mechanism which rejects radioactive carbon atoms while still allowing the absorption of normal carbon atoms. Thus, at death, these plants and the animals which eat them have abnormally low levels of carbon-14. When these remains are dated, they, therefore, give the false impression of being very old. Unfortunately, experience has shown that it is not a completely reliable system, and that it only seems to work for remains of living things which have died within the last few thousand years, like this ancient statue made from the branch of a tree. What methods do evolutionists use to try to date such things as minerals and rocks, which they suppose are millions or even billions of years old? Or these beautiful Swiss mountains and their stone formations?
Besides the C14 method of radioactive dating, there are, of course, other methods of dating with radioactivity. You can use the C14 method, which decomposes into N14. You can use the potassium-argon method. Potassium decomposes to argon, and you can also use the uranium-lead method. Those are the three chief methods of radioactive dating.
To date objects by the carbon-14 method, you must have things that were once alive, like wood or bones. The three other methods which Professor Wilder Smith mentioned use inorganic dead material, like rocks and volcanic stone. But the principle remains the same. There is some kind of decomposition process. By measuring the ratio of the radioactive material that is left with the amount of decomposed material, you can try to date your sample. Take, for instance, this rock. In some rocks, we find the element uranium. As you know, uranium is radioactive, like carbon-14, but it decomposes much more slowly. The uranium in this rock decomposes into lead, plus some other elements. It would take about 4.5 billion years for the original amount of uranium to be reduced to half that amount. During these complicated chemical processes, the gas helium is formed. The helium is also interesting, but we'll come to that later on. Let's look now at a not-so-scientific process, the water tank experiment. Although it's not especially scientific, It's still very interesting because it shows the three basic assumptions of all the radioactive dating methods. Water flows from one tank to another with a certain speed. You would think that by measuring the level of water in both tanks and comparing them to one another, you could determine exactly how long the water has been flowing, especially when you know the present speed of the flow. It seems logical, and at first, no one would object to the results of your experiment. But when you do that, you make three presuppositions. You might have thought that at the beginning of your experiment, the second tank was empty. But it wasn't at all, as you can see. A constant speed. You might have thought that during the whole experiment, that speed was constant. But it wasn't, as you will see. You thought so because you didn't reckon with external influences. But what actually happened? While you weren't there, some meddler sneaked into the lab and did two important things. He changed the speed of the water and then added another bucketful. Oh dear. Because you didn't know these things, your careful calculations and results are of no value. The present flow time is shorter than you thought. The second tank was already half filled. And the meddler not only changed the speed of the flowing water, but added another bucketful.
Now, all those methods, the radioactive methods, suffer from three main weaknesses. In the first place, one never knows how much radioactive substance was present at the start. And as you've seen from the water tank experiments, unless you do know how much was present at the start, you, on a theoretical basis, just simply can't calculate how long the reaction has been going on and therefore how old your sample is. That's the first difficulty in all these methods. The second difficulty is, as you've also seen from the water tank experiments, that the rate of decomposition, the rate of radioactive decay, must remain constant. If it changes, then of course you can't calculate a date at all. Now, we have adequate proof that the rate of radioactive decay can change. Now, there's no guaranteeing then that the rate of radioactive decay has always remained constant.
Numerous radioactive isotopes have been shown to have variations in their decay rates. Dr. Robert Gentry of Oak Ridge Laboratories Atomic Energy Commission has recently proved that radioactive decay rates have also varied in the past. Radioactive decay within crystallized minerals leaves minute concentric rings of discoloration called radiohalos. Variations in the measured ring diameters clearly indicates that decay rates have changed in the past. Without an absolutely constant decay rate, radioactive dating is highly unreliable.
Now, the third difficulty in the method is this, that the concentration of the various parts of the radioactive system must remain constant throughout the experiment. If you put in C14 during the course of the experiment, the sample will appear to be much younger than if you wash C14 out. Now, all those things tend to make the radioactive methods of dating insecure. But there are other methods not dependent on radioactive decay which can be used for dating.
We already saw that during the decomposing process, which changes uranium into lead, helium escapes into the atmosphere. Dr. Melvin Cook of Salt Lake City, a former Nobel Prize nominee, studied this gas, helium.
Helium is an interesting thing. In the atmosphere, it's present to the extent of about 1 million billion grams. However, that's a small amount compared with the amount that would be in the atmosphere if all of the helium that is being generated in the Earth and exuding from the Earth's crust were to accumulate in the atmosphere and the Earth were still to be old.
Evolutionists claim that the Earth is 4.5 billion years old. Now, it's not possible for helium to escape from the Earth's atmosphere. It is also a fact that from the sun, even more helium enters our atmosphere. So, if the Earth were actually 4.5 billion years old, our atmosphere would be saturated with helium. But it isn't. The amount of helium we measure is only a fraction of what the evolutionists thought there would be.
Now, the question is, where is the helium? If the Earth is billions of years old, as I said, then that helium would have saturated the atmosphere up to 1 million times greater than we now have. Actually, we've studied this question. People have thought, well, the Earth is old, and the helium just exudes from the atmosphere, just goes out. They call it an exosphere. They say that the helium actually comes right out of the Earth's atmosphere. Actually, in studying that, a physical chemist has a handle on that. He can tell whether that's true or not. And I put the handle to it and examined it in about 1955 and found out that there's no chance whatsoever that helium could be leaving the atmosphere. And so I asked the question, where is it? Where is the Earth's radiogenic helium? The answer seems to be that the Earth is just not that old.
According to Dr. Cook's measurements, the age of the Earth is actually about 10 to 15,000 years. Endlessly, it seems, the universe stretches out around us. Galaxies of every shape and form can be seen by man's ever-improving telescopes. But the more we see, the less we understand. How old, for instance, is the universe? No one can really tell. But the astronomer, Professor Harold Slusher of El Paso, Texas, says that there are a number of reasons to suppose that the universe is relatively young. But let's stick to the age of our planet, Earth, and see what astronomy has to say about that. Professor Slusher.
It is a much easier matter to determine the age of the solar system and the Earth because we have a great deal of data. Things are much closer at hand. So for the astronomer, there are a number of indicators, as it appears to me at least, that would seem to indicate an age of no more than 10,000 years at the very most for the solar system and the Earth. I would take that as a maximum age for a number of reasons. One is the very rapid breakup of comets in the solar system. Comets, as they swing around the sun, are torn apart literally by tidal effects due to the gravitational attraction of the Jovian planets and the sun. And then there's the solar wind blowing at a tremendous speed out of the sun on the order of 250 miles per second to 600 miles per second. That literally sweeps a comet clean. And then there are very peculiar things happen to comets, such as explosions and the nuclei of comets. These tear comets up very rapidly, and it seems that the maximum age for the lifetime of a short period comet is about 10,000 years at the very most, and more than likely it is somewhat smaller than that value even. Now, it's believed by most astronomers that the comets originated at the same time that the solar system did. Therefore, if you determine the age of the short period comet, you automatically have the age of the solar system, which can be no more than 10,000 years. When you look at the dust on the moon, you certainly come to the conclusion that the moon must be quite young, and if the moon is young, the Earth is young. You see, dust from interplanetary space is continually being deposited on the surface of the moon. It's coming in at a rate of about 14,300,000 tons per year, all the way up to maybe 10 times that number. So after 4.5 billion years to 5 billion years, you ought to have a layer of dust on the moon around, 440 feet to around 990 feet, something like that. But on the moon, you have a layer of dust that is roughly 1/8 of an inch to 3 inches in thickness. And just a few inches will give you an age for the moon of around, 7,000 years to 8,000 years, as a matter of fact. So looking at the surface of the moon, the absence of dust, which ought to be a very excellent indicator of the age of the moon. You find an absence of it, it looks young, and instead of a huge layer, which you'd say it is very old, the moon has a small layer, very young. So I would say that the moon is quite young. If the moon is quite young, then of course the Earth itself must be quite young, because certainly the age of the Earth and the moon, even the evolutionists say, are roughly the same age.
The dust comes from space in the form of meteors and meteorites. But when we measure the amount on the Earth, we come to the same conclusion. There is no more meteoric dust than could be accumulated in 10 to 15,000 years. The public has generally been given the impression that there is no evidence that the Earth and the universe are young. However, there are many other such indications. Since 1836, over 100 different observers at the Royal Greenwich Observatory and the U.S. Naval Observatory have made direct visual measurements which show that the diameter of the sun is shrinking at a rate of about 5 feet per hour. The diameter of the sun is so large that this shrinkage goes unnoticed over hundreds or even thousands of years. Yet the sun does continue to shrink. Records of solar eclipses imply that this relatively rapid shrinkage has been going on for at least the past 400 years. As far as researchers can tell, this rate has been constant since the original formation of the sun. Using the most conservative data, it would seem that the sun would have had twice its present radius only 100,000 years ago. 20 million years ago, the surface of the sun would have been touching the surface of the Earth. Some experts have concluded that the sun would have been so large, even only 1 million years ago or less, that no life could have existed on the planet.
I believe when you add all of these effects up, one certainly comes to the conclusion that the solar system and the Earth is quite young, no more than 10,000 years, and I certainly believe the universe itself is no more than that. I think all of these objects are essentially the same age.
For ages, ships have searched their way over seemingly endless oceans. For the last couple of hundred years, they've used a well-known instrument to guide them, the compass. The needle of the compass always points to the North Magnetic Pole. It does so because around the Earth lies a magnetic field. We know that this magnetic field also decays. Every 1,400 years, its strength is reduced by 50%. So, when we go back into history 1,400 years, the magnetic field was twice as strong as it is today. Another 1,400 years before that, it was 4 times as strong as it is now, and so on. Professor Thomas Barnes, physicist at the University of El Paso, concludes,
if we went back 10,000 years, the Earth's magnetic field would have been as strong as the magnetic field in a magnetic star. Well, now, a magnetic star is like our sun. It has a nuclear power source. Surely our Earth never had a nuclear source like the sun. And surely our Earth never had a magnetic field, certainly no stronger than a star. That would limit the age of the Earth to 10,000 years. Other physical arguments would limit it to various amounts. But science could definitely say, from the greatest physical evidence, the kind of physics that we design radar sets with and communication sets, same kind of physics, would tell us that the Earth's magnetic field cannot be more than, say from 6 to 15,000 years.
The Earth, a small, beautiful spot in the universe, perhaps created not so long ago. What do dating methods teach us?
Now, we've looked at various methods of dating. Some of the dating methods have given very old ages for the Earth, and some of the dating methods we've looked at give very young age, a very young age for the Earth. But both the methods of dating suffer from the same difficulties, and neither of them are conclusive. Now, the Bible teaches fairly strongly that the age of the Earth is not so very great, and that creation took place not so very far in the past. In recent years, a new method has been worked out for dating based on radioactivity, known as the halo method by Robert Gentry. And this method, too, in contrast to the other methods, does point to the Earth being quite young. So we have scientific evidence in support of the biblical view that the Earth may be very young. Now, if that is a fact, and if that is confirmed, and we're not going to be intolerant on this point, if that is confirmed, then of course the long time periods which are absolutely necessary for evolution just don't exist. And if they don't exist, then of course the whole idea of evolution is in trouble, because you can't get a man produced in a short time by chance. You must have the long time periods. Now, the Bible does teach that the Earth may be young. If it is young, then of course we're absolutely dependent upon a creation on the part of an eternal God to have done the work necessary to have produced a creation such as we see today.